Chapter 3G, we're looking at the coefficient of determination. Now, the coefficient of determination is simply r squared. We're remembering that r is the correlation coefficient. Now, before we talk about what this coefficient of determination actually means, let's look at how we can calculate it. Let's say we have our correlation coefficient equal to 0.7. Well, in your calculator, you can just put 0.7 squared, 0.49. So you've got r squared, your coefficient of determination, is equal to 0.49. Or, often, they quote it as a percentage, multiply it by 100 to get 49%. Now, if we think about the strength of a scatter plot with r of 0.7, it might look something along the lines of this, okay? Because r is a positive number and it's 0.7, so the form is fairly strong. It's going to have a positive upward trend that is fairly linear. What happens if we look at r equals negative 0.7 though? Okay. Now this is really important. If you want to square a negative number, you have to put it in brackets like this and then square it. So what you're saying is you're squaring all of negative 0.7, because when you square a negative number, you still get the positive number. It's like when you multiply a negative number by a negative number and you get a positive number. Now the reason that's important is because your calculator, if you put negative 0.7 squared, it will actually give you that negative there. That's because your calculator, when you type it like this, it automatically, for some reason, it thinks you're asking it to do this. You're asking it to square 0.7 and then put a negative in front afterwards. That's why you need to put the negative inside your brackets if you want to get the right number. And if we draw a scatter plot that roughly represents this one, it will have the same sort of strength, but because r is negative, it's got that downward trend. Now there's a problem that arises here. What happens if you're given the coefficient of determination and it's 0.49 and you're asked to find the correlation coefficient? If r squared is 0.49, is it going to be negative 0.7 or positive 0.7? It could be either. So if you're asked this question and you're not given the graph to show you, r could be positive or negative 0.7. If you take 0.7 squared, you'll get 0.49. If you take negative 0.7 squared, you will get 0.49. However, if you're given the coefficient of determination and they also give you a graph, they also give you a scatter plot, and they ask you to find out r, well, you know it's got to be positive or negative 0.7. Using your graph, you can figure out whether the trend is positive or negative. In this case, the trend is clearly negative, so you would know that the correlation coefficient must be a negative number, therefore negative 0.7. Now let's focus on how do we interpret the coefficient of determination? What is it actually telling us? So the coefficient determination as a percentage, because remember we can list it as a decimal or a percentage, as a percentage, tells us the variation in the response variable by the variation in the explanatory variable. Now, personally, this explanation does not give me a lot of information without an example to go with it because it's worded fairly confusingly. So let's look at an example. We have the relationship between a person's height and their weight has an R-squared value of 64%. The height is the explanatory variable. We are asked to interpret the coefficient of determination in terms of these variables. So this is a very standard way of doing it. We have the coefficient of determination tells us that on average, 64% of the variation observed in people's weight can be explained by the variation in people's height. The remaining 36% can be explained by other factors such as age, sex, or lifestyle. So when I've said the remaining 36%, that's because 100 minus 64 is 36. That's just the remaining percentage that remains. So how did I know how to word this and what pieces of information to put where? Well, there's a standard template that we can use to answer any question that asks us to interpret the coefficient of determination. So here is the template that I used for that example just before. The coefficient of determination tells us that on average, whatever your coefficient of determination is as a percentage of the variation in the, and you put your name of the response variable in here, can be explained by the variation in the, put your name of the response, the explanatory variable. The remaining something percent, now this remaining percent is just whatever's left over from your coefficient of determination. So for example, if this was 70%, the remaining would be 30%. If this was 40%, this would be 60%. If this was 98%, this would be 2%. It can be explained by other factors such as, and then you use your imagination to figure out some other factors. For example, in the last one, when we compared people's weight and their height, the other factors could have been their age, their sex, or their lifestyle. Now here's an example from the 2016 VCAA Exam 2. It's question 3C and it's worth 1 mark. It says, the coefficient of determination for the association between the variables apparent temperature and actual temperature is 0.97. It asks to interpret the coefficient of determination in terms of these variables. So having this template in your notes and knowing what to put where can get you an easy mark in a SAC or an exam. So because we have this template, all we need to know is what pieces of information to put where. Well, the coefficient of determination tells us that on average, this percentage is your coefficient of determination. So you would put 97% there. Your response variable, if you remember, a response variable is always your vertical axis. So in here you would have apparent temperature. Your explanatory variable is your horizontal, so you'd have actual temperature here. The remaining percent, because this is 97%, the remaining percentage is 3%. And then other factors for this one, you could think, well, apparent temperature is what we feel as a temperature as opposed to the actual temperature, so possibly a factor could be how much wind there is. because the more windy it is, I guess the colder it is.